Okay, electronic configuration. There are a couple of things you need to know about electronic configuration, which I'm going to go through with you now. Rule number 1. The first shell can contain 2 electrons. Rule number 2. The second shell contains 8 electrons. The third shell, 8 as well. When you go past that, you get up to 18. The fourth shell contains 18, but you don't need to know that for the exam. When you have a look at any element from the periodic table, so for example lithium, you should now be able to tell me how many protons, neutrons and electrons there are. For electronic configuration, you only need to know the number of electrons, which in this case is 3. So you start off by drawing your first electronic shell. We've got 3 electrons, but only 2 can go on that first shell. So put your 2 electrons there. That leaves you with 1 more electron, which goes into the next electronic shell. This pattern continues for any of the elements up to element 20. If we were to choose aluminium, which has 13 electrons, in the first shell we can have 2, which leaves us with 11 electrons left. The second shell can only contain 8 electrons, which gives us 3 remaining. Those go in the outer shell. There's a nice little trick that tells you what group and what period an element is in. So if I were to give you an unknown element, you could have a look at the number of electrons in the outer shell. In this case, we have 5. That tells you the group the element is in. The number of shells tells you the period it's in. When you look at your periodic table, you can see that the groups are in columns going down the periodic table. The periods go across in rows. Therefore, if we go back to our unknown element, which is in group 5, period 2, we can have a look, group 5, period 2, and we know we've got nitrogen. The way we can check that, we have 1, 2, 3, 4, 5, 6, 7 electrons, 7 electrons. So recap, the number of electrons in the outer shell tell you the group the element is in. So if I were to draw any outer shell, I could choose any one. If I put 1 electron in the outer shell, I'm in group 1. If I put 2 electrons in the outer shell, I'm in group 2. 3 electrons in the outer shell, group 3, and so on. The only one this doesn't work for is group 8, and there's a simple reason for that. Group 8 is actually now known as group 0 because of helium. If you were to say group 8, you would expect to have 8 electrons in the outer shell, but helium, which only has 2 electrons, only has 2 in the outer shell. The difference is it has a full outer shell. It is stable. And when we talk about ionic bonding and covalent bonding, you will understand what that means. So helium has a full outer shell. So does neon. So it's called group 0, the unreactive group, because it has a full outer shell of electrons. Finally, there is also a way of writing down the electronic configuration without having to draw the shells. In some exams you might be asked to write the electronic configuration, not draw it for any one from the first 20 elements. So what you need to do is simply write how many electrons there are on each shell. So for lithium, it has 2 electrons in the first shell and 1 in the second. So it has a written electronic configuration of 2.1. The second one here, which is neon, has 2 electrons in the first shell and 8 in the second. So you write 2.8. And finally, the last one here, which is aluminium, you write 2 for the first shell, 8 for the second shell, and then 3 in the final shell.